this is a Google Practitioner session, and I'm Chris Fry. I'm the outgoing treasurer of IAF, and been a board member for 2 years now. And I'm here to introduce our speaker. It's my pleasure to welcome Evan Pardo. I'm at Google. Evan's also at Google, and I invited him to come and give this talk today. Evan leads the data science team for our devices and services product area. He's been with Google for a number of years and has also worked in sales operations and in finance at Google, and was also previously at Apple. Across all those roles, he's been heavily focused on forecasting, and I've been very impressed with the work that he's done with devices and services. So look forward to sharing that with you. Welcome, Evan.
Hi, everybody. Thank you so much for being here. Really excited to talk to you all today. So as Chris said, I work with Google's Devices and Services organization, and am very focused on forecasting demand for these amazing products that you see behind me. Our portfolio includes our Pixel phones, our Nest and Chromecast and home devices, our Fitbit watches, Pixel Watch, the list goes on. So it's an exciting area to work on, and I'm excited to talk to you all about forecasting for it. Before I do, I just want to give a quick but heartfelt thank you to the incredible team of people that I get to work with every day. Anil, Tanvi, Umair, Jordan, Brad, Banu, Mackenzie, and Lissa. I think I got a full list there, but all really brilliant people to work with, and without Umair in particular, who's the lead data scientist on this work, really wouldn't have too much to talk about with you all. So thanks to them. I'll start today going through an overview of how forecasting is important for the organization. Oh, thank you so much. This is going to be very useful for me. How forecasting is important for our organization. Some challenges that we face with the complexity of our business. How we use statistical models to model for strategic processes, the tech and design behind what we do, and then I'll end with a detailed view of how we accomplish our modeling. And excuse me while I break into this water. Still not used to these lids. So for our consumer hardware business, the forecast is an absolutely foundational analytical result that drives strategic decision-making throughout our organization. So our sales team, for example, will plan what promotions to run, when to run those promotions based on the forecast. Strategic targets are set based on what we think we can achieve under certain situations, whether they're revenue targets or volume targets. And the forecast actually also drives relationship management with key partners. On the operations team, the forecast will drive the manufacturing schedule, when and where we're going to manufacture, what contracts we're going to sign with logistics providers, with component suppliers, and actually everything down to the factory capacity that we plan for. How many lines are we going to install at factories in order to produce devices? I will add that this is particularly important for products like our Pixel phones, where we really only have, give or take, a one-year life cycle on the product. So really important to get the forecast right enough so that those big upfront decisions are made well. On the finance side, our revenue and profit planning and forecasting for the organization, and also budgeting for key strategic drivers like promotion and marketing campaigns. And on the product side, we actually, the forecast drives things like what great new features are going to be in devices. Will this feature help us achieve our goals or not? It's a key question that drives rationalization of those features. So incredibly important analytical result underlying the entire planning function for the organization, and yet until recently this was done effectively completely manually. There's actually a really good explanation for this, which is that Google hardware is a pretty new business. So we're only on our 8th generation of Pixel right now, and until a few years ago we just simply didn't have enough history of weekly data to start building major automation with statistical models. There were some past attempts at building ML tools, and those struggled to gain traction for reasons I think that have been discussed in several talks this week. But data availability, cleanliness, the amount of history that we had, and then very critically, incompatible processes. There's just a fundamentally human element to turning a forecast into insight for an organization. And the processes that the business was relying on didn't necessarily work with fully automated forecasts. So my team and I, looking at this, set out to build a statistical or ML or AI forecast. We didn't know what at first, but we knew that we wanted to tackle this problem. I will add that as we started to look at the scope and complexity of the problem, it was actually really significant. Roughly 40,000 series need to be forecasted every single week, and that number is constantly growing as our business scales. We have now roughly 7 years worth of history, over 100,000 total series in our context, and we also need to forecast as much as 3 years into the future. And so, that forecast horizon relative to that history makes this a very challenging problem. So we set some goals for ourselves. First, we wanted to have clear and measurable accuracy. Basically, we wanted it to be so clear that if you looked at our results, that they were better than whatever the business had in place. We also thought that these metrics should be really easy to interpret. So, as we're presenting to people who aren't necessarily experts on statistical forecasting, we wanted to be very, very clear that the manual process was not going to deliver results in the same way that our tool would. We also wanted to facilitate full automation. We wanted this forecast to run automatically every time it was needed to run, and we wanted it to very correctly and automatically update to capture new trends. And finally, we wanted to facilitate seamless process adoption. We wanted to integrate into our business systems, our planning systems and financial systems, such that planners could be very easily able to adopt these results without having to change everything about what they do. And we wanted to focus on what we call planning by exception, which is basically as much as possible automating away the need for human intervention in the forecast and focusing just on those key moments where there's outside information that a human needs to really include in the results. And that seemed like a good set of goals to set. And what we found is that that is not remotely as clean as we'd like it to be. First, what even is accuracy? Looking at different error metrics, MAPE, MAE, RMSE, or forecast accuracy, which is ostensibly something like 1 minus MAPE. But then what MAPE? Are we looking at time aggregated or hierarchy aggregated MAPE, or both? Or are we looking across snapshots or across a longer horizon like a 1-month offset or 1-quarter offset MAPE? And the answer is all of the above were absolutely required based on different key stakeholders in our organization. Trying to convince people that this forecast is better than what they had before is not simple at all. And to be very honest, we've spent more time on this blue section up at the top than we did on building the initial model. The next thing is that manual intervention is absolutely necessary. I think that this is probably a controversial statement based on some conversations I've heard this week. But at least in our business, data is inherently imperfect. There are key insights that are tracked outside of databases and lost. And we also don't always plan detailed strategy related to things like promotions a year plus in advance. A lot of times that's being planned in a very short strategic time frame. And so that data just simply doesn't exist for us to build a fully automated model that gives a number and finishes the job. CPFR, or Collaborative Planning, Fulfillment, and Replenishment, this is a process where our planning team will get literally on the phone or on a video chat with the planning team from our key retail partners, and it will discuss strategy and forecasts and upcoming activities that those retail partners themselves are going to execute. And that's, as you can imagine, very, very critical information to get this forecast right, and that information lives in the heads of these planners. We haven't found a feasible way to get dozens of individuals to somehow perfectly keep a database updated with all the valuable information in their minds. I guess 2 more points here. So the last is that some inputs like promotional strategy are themselves actually cyclical. So basically, if forecast is too low, the team plans higher promos, and so on and so forth. This is a really healthy thing for an organization to go through. This is exactly what you want if you're growing a business, and yet it makes it effectively impossible to have an accurate forecast because the forecast should invalidate itself effectively. The last, change is very painful. We've got brilliant, experienced planning teams working 80 hours a week sometimes. I show up with a fun new model and they look at me like I'm crazy. And that makes sense. We need those people to be executing the business, and supporting those teams through this change is inherently difficult. So looking at this, what we decided to do was to step way back and focus on what a really healthy, high-level business process looks like for this strategic forecast cycle that we were hoping to support. So this is, I think, a huge oversimplification, but this is how I kind of look at the world or summarize the world in my head. When an organization is doing strategic forecasting, there's often a starting point, which is a target that's set. This could be a volume target to achieve an economy of scale in the factory. This could be a financial or revenue target. Lots of reasons we might have a target, but a target is set nonetheless. And there's a first pass at a forecast that is done based on what we have today. What can we achieve? And usually, if a target is set aggressively, what you can achieve is not going to hit that target. And so then the strategic functions in your organization, your sales team and marketing team and product team are going to kick in. Sales is going to plan promotional strategies. Marketing will plan campaigns. Product will plan new features. And all of those things are going to, in turn, incrementally impact that forecast, pushing the forecast up to target. And eventually the forecast is going to achieve the target, at which point the business goes into execution. The units are manufactured, the strategies, the promo strategies and marketing strategies are run, et cetera. I've got this green box on the bottom here. So really, really critical for this to function in a healthy way, you need a model that can comprehend the difference between an organic starting point in your forecast or a baseline, I'll call it, and then these inorganic strategic inputs that drive uplift above that baseline. And this model, the hope would be, if you had this model working perfectly, that it would sort of start you out in that red box and then facilitate the interaction through the yellow box. One thing that's important to call out about a model like this is that the baseline piece of it and the strategic uplift piece of it might actually be relevant to very different people. The baseline is a starting point, but that uplift piece might be used by sales or marketing or finance or product in totally different meetings with different stakeholders driving different strategies. And bringing all those inputs together into one central place is potentially very challenging and requires a unique modeling approach. So what happens if you don't have a model like that? That's a very difficult model to achieve. Is you get something that looks like this. And I'll start by saying this chaotic cycle is actually, again, a very healthy cycle for an organization that is trying to do the right thing with its product, but doesn't necessarily have the ability to create the ideal model. So you have your target, and then you have your starting forecast, and then you've got people in your sales team building a spreadsheet where they do some sort of tops-down, high level of aggregation, forecast, and then they're going to run a promo, so they multiply everything by 1.2. You've got some teams where they do, basic linear regression to get a baseline in a spreadsheet at, say, a middle level of aggregation. And then there's some big partners that are doing strategic activities, and so they go in and override those forecasts with made-up numbers that may be made up very well, but are made up nonetheless. Lots of different mashed together approaches to forecasting. There's two here that I actually want to call out that I would call almost dangerous for the organization. The first is setting the forecast equal to the target. This, if you think about it, for an organization that successfully hits its targets, setting forecast equal to the target is a really fantastically accurate forecast, but one that is entirely unhelpful in terms of making good decisions about how to get to that target. And the second is setting the forecast equal to the partner forecast. So I mentioned CPFR calls where we're receiving key information from our partners directly. A lot of times those partners share forecasts with us. But I've talked at length about how those forecasts are themselves going to drive strategic execution through our organization. So if you rely too heavily on the partner forecast to drive your forecast, you're actually giving control of your strategic operations to your partners, which is not something that you would want to do. So looking at this cycle, my team and I worked to build a modeling framework that allows for us to overcome a lot of the challenges that I've talked through, and hopefully lays a groundwork to facilitate a more ideal version of this process. So I'm going to talk more in a few slides about how we use Vertex AI to get these results. But the first thing I'll do is talk through our modeling framework. And it's a pretty simple modeling framework, conceptually, though potentially quite difficult to build. On the left here, we have a backward-looking baseline. So again, we're defining baseline to be an organic, seasonalized run rate. What would we do if we didn't execute major strategies? But very notably, that baseline excludes the effect of promotions. So we use a counterfactual simulation of the past to determine this organic seasonal run rate going back through history over our products. This gives us some really key results that we're able to use effectively for some really important strategic analyses. For example, strategy effectiveness analysis. So if we run a major promotion and we want to see, did it work well? What was our uplift from that promotion? This result allows us to go back and see that. And it also facilitates like product modeling, which is something I'm going to talk about on the next slide. So I'll come back to that. The next capability that we have here is our forward baseline forecasting. And this is sort of our core capability. We've trained our AI on all of our history. And we use it to generate that depromotionalized, forward-looking organic run rate. This, we hope, as we build it correctly, ends up being the foundation for the strategic planning cycle that I mentioned before. So that starting forecast going into those strategic planning discussions. One thing that I will call out about this forward baseline is that this is also a really effective way. If you're managing thousands of different intersections globally, this is an effective way to automate, not everything, not your key partners, but potentially 80% of the intersections that you're trying to forecast aren't necessarily going to be on promo very frequently. They're kind of business as usual, or they're potentially older or low-touch products. There's lots of reasons why you might feel comfortable as an organization allowing this baseline to just drive that planning process for those products. So there's a huge amount of automation that can come just from this baseline. The last capability that we focus on then is a separate set of simulation capabilities. And we're, if you can't tell, very heavily focused on promotions in particular. And so we focus on building a simulation tool that allows our planning teams to look at lots of different types of promotions that they could run in the future and see what incremental effect those promotions are likely to have above and beyond the baseline starting point that they're working with. And so with all these tools together, our hope is to facilitate this strategic process that we were talking about earlier. Now, one thing that's really important to call out here is that we're using a trended model. And so all of this requires at least one data point. Now, Vertex does a really good job of picking up on trends very quickly. But as I think many of us are familiar, cold start forecasting with no history on a new product is very, very difficult. And the level of granularity that we're running our forecast at is very hard for us to generalize across product generation. Possibly impossible. We haven't figured it out yet. And so we needed to get a bit creative with how we think about pre-launch forecasting. And so I'll direct you back to the like product modeling that I mentioned on the left there. So what we did is we actually looked to our business partners to see how they think about forecasting ahead of a launch. And what we landed on is a really straightforward, potentially oversimplified process. You pick a product from the past. Let's say, several months ago we were forecasting Pixel 8a, and you would pick Pixel 7a as your like product. And you'd start with that, and you'd assume some kind of gen-on-gen growth or gen-on-gen promotional changes above and beyond that. And you'd land on a new volume for your Pixel 8a, or your new generation product. Now, the really difficult thing about doing that without a baseline approach to modeling is that, let's say you had a product where you ran an X% promotional budget, and your new project you're running an X plus 10% promotional budget. What impact is that going to have? And oftentimes when teams start to do that analysis without a really robust elasticity tool, it kind of turns back into those guess spreadsheets I talked about earlier. So what we have with this backward baseline is the backward baseline for the prior generation product. And so we can start with that depromotionalized baseline, and then we can do a couple simple scaling effects on top of it. So the first is we can talk to our marketing team. The marketing team has got loads of marketing research that they're pulling in, and has likely got a sense of what the total available market growth is going to be. I understand as I'm saying this is not a statistical forecasting problem, but the business has often aligned on strategic growth targets. And so it's really important for us to be able to intake those, if not forecast them, and they're actually very, very difficult to forecast with the data that we have access to, since we don't have access to data from our competitors. So we'll get this total available market, or TAM growth assumption, from the marketing team. But often that's not a huge number. It's not going to be like 50% total available market growth. In addition, we can see, so if we look at this graph on the left-hand side, that blue baseline versus the black actual line, the delta between those two is the promo uplift, in this case from our past generation products. So we can take that exact same promo uplift linearity, and we can apply it on this new scaled baseline as a % uplift above that baseline. And this is painfully simple, but we've shown it to work very, very well. You can just linearly scale that up or down if your promo budget is changing by a relatively small amount, gen on gen. So if your promo budget is increasing by a few percentage points or decreasing by a few percentage points, you can just scale up or down that uplift. This is something that could certainly be improved, but without sharing details I can't share, I can tell you that this is actually working really, really well for us. It is definitely working well enough to facilitate strategic discussions ahead of the launch of a product. And so yes, in this green box, you add all of these new inputs together, and you've turned your prior generation product into a new, your new generation forecast. One thing I'll call out here is that the key statistical result here really is that backward baseline. And so when we laid out that framework on the previous slide of the 3 key capabilities that we've developed, this is just an application of that backward baseline. And that backward baseline is actually one of the more challenging problems that we've tried to solve. So how did we build this? I mentioned we use Vertex AI, AutoML. There's some really great modeling architectures in Vertex. In particular, we use a TIDE model, and I've got a slide on that coming up, or time series dense encoder. So next slide, I'll talk more about that. So we've got years worth of transactional system expertise that's been built up in our organization. All of those transactional systems feed into a business data abstraction warehouse. So we've got a warehouse which has really made access to master data, sales, planning, inventory fulfillment. All of those different data sets are very readily available, nicely keyed in this abstraction layer. From that, we keep that in BigQuery. And from that layer, we're able to do our feature engineering, feed our training table into Vertex, train our models in Vertex, push the results and the predictions back into BigQuery, and from BigQuery, we serve those to our downstream users. So a couple kind of statistics about what we're running here. We train on 100,000 time series. It's about 10 million rows and 60 features that we're using. Not all of those are super important features, but we found that these seem to work well. And then we're also putting just an insane amount of horsepower behind this. So it's an AutoML, so it takes a long time to throw the kitchen sink at this to figure out how to model it. We actually trained 5 different models. Each one of those models is going to train on 1,000 parallel processes for 24 hours every single week. So it's a pretty beastly task. It's fun getting to leverage cloud in this way. And why do we train 5 models? So this is actually unnecessary. We're kind of going for those last few percentage point of accuracy. But what we found is that certain parts of our business, certain series, especially, for example, low volume and low volatility series, actually do better if a model is trained with MAE versus RMSE, whereas high volume or higher volatility series do better with RMSE. Similarly, the length of the look-back window is a parameter that yields different results across our business. And I mentioned we use the TIDE architecture. There's also a learn-to-learn architecture, which I think has LSTM technology in it in Vertex. And each one of those sort of shines in key moments through our business. And because this is a forecast that drives such a huge economic impact, we're willing to make the investment in multiple models to drive that further few percentage points in accuracy. But TIDE wins out, I want to say something like 70% of the time. The TIDE architecture is the one that wins in our champion selection process. So the TIDE model, I've got a slide here. I did not make this slide. I'm boosting this from some brilliant data scientists at Google who published the paper that I list down there at the bottom. I encourage everybody to look it up. But the TIDE model has some great value for our business. First of all, it's really well set up to handle this exact problem that we face. First, it does per time step covariate feature embedding. And what that means is that you can actually differentiate between variables that are only available in the past and variables that are available both in the past and the future. This is really important in supply chain, where you might have a variable like the level of inventory that you have available to sell. We know what that inventory is today. We know what it is in the past. But we have no idea what that inventory is going to be in the future, and in fact, that inventory is circularly related to sales, which we are forecasting. Higher sales, lower inventory, et cetera. Or maybe higher inventory because we build more of it. So being able to differentiate between those features is really valuable. Also, this is actually not using an LSTM block. This is a simpler architecture. It's using it's a DNN-based architecture, and so it trains very, very quickly, and it can easily handle super long context windows, keeping kind of equally the full context window available as it feeds through the network. And so this is something that allows it to learn things like if you run a particular marketing campaign, there could be effects months later. That long-term effect is not lost through, LSTM layers. And finally, we still train for 24 hours because we're training some LSTM models as well. But actually, we saw the ability to reduce our training time switching to Tide, I think, by a factor of 5. So really big improvement when we switched over here. We also anecdotally saw our accuracy improve very significantly. And so the results that we're getting with this approach, first of all, when we backtest our model, looking at MAPE, against our business plan of record, or POR, that's the forecast that our business team is generating, we see that about 70% of the time we're actually able to improve or reduce our error. On average, that error is being reduced by about 30%. And this is something that we've seen consistently as we continue to test it. And also through, as we're driving adoption, this is not a fully adopted thing yet. We're still working to drive adoption. But as we've driven adoption with our teams, we're hearing that once the adoption occurs, there's about a 70% reduction in the amount of time it takes to build a forecast. You'll notice that this isn't a 100% reduction, and that's because we're not trying to fully automate everything. We're creating that baseline and simulation capability, but it is something that's facilitating speed through the process. I'll call out bullet point 3 and 4 here too. So Vertex excels at cross-generation generalization. We've seen some really interesting case studies where there was actually a point where we had a broken data set. We had the wrong end-of-life date for a past, I think it was a Chromecast. And we were wondering why our current Chromecast forecast had this weird drop out in the future for no apparent reason. And the answer is that it had learned to follow that past Chromecast, and it was assuming it would drop earlier because we set the wrong date in the system. So we fixed the data, the model got better. So we see these really interesting moments where the model has learned across multiple years which products best represent the run rate that it should forecast going forward. The other thing is that this is Vertex AI, so we were able to build this with a really small development team. Maybe 40% of my time and one other person working, 100% time is all we needed to get most of the way through the initial build out and testing of the model. And it was only when we started working with our business partners that we scaled up the size of the effort. So really, really excited with these results. I wanted to end on a couple slides that just go into more detail about how we implemented this and show a few examples. So this is a past baseline. So first, how does this work? So the first thing I'll say is that all three of these, the past baseline, the forward baseline, and our simulation capabilities are using the same AI. It's the same champion selected 5 models from our Vertex pass-through. What we do with the past baseline is we train this model on all of our history, including promotions. And then we actually set the model back in time. So this is data that technically the model's already trained on. And we build this rolling context window setup in our data set where we take the entire context window with 1 week at the end where we remove the promos from that week, and we ask the model to repredict that 1 week with the effect of promotions removed. Then we union into the data set a 1-week shifted rolling context window with the next week turning promos off, and so on and so on. So we roll 1 week at a time through our history. Very quickly, this turns into a several 100 million row prediction table because we're unioning potentially, let's say, 100 different tables together, each with a full context window, since we have a very long context window feeding the model. You could do this one at a time, but that would take a very, very long time. So what's nice with our cloud setup is that cloud will scale up the compute power to facilitate doing all of that all at once. And so in just a few hours, we're able to calculate these backward baselines through this rolling context window approach. In the examples here, you'll see, basically backward baselines behaving like you would hope backward baselines would behave. You see that the spikes driven by promotions are in the black lines. Those are the actuals. And then the blue line beneath is typically much smoother. You see some nice things, though. Holiday seasonality actually jumps out. This is a depromotionalized seasonality. This is very, very hard to test. We are not going to turn off promos on a key holiday like Black Friday to see if this model is correct. But what we are very much hoping, and what we see, is that the model is correct in the cases where, for various reasons, we don't run a promotion, maybe a smaller partner or a country that isn't as strategic at that moment. So we get this very consistent and clean holiday seasonality that comes out both in our backward and our forward baseline. You can also see, and this is a nice sort of testable thing, because this is effectively an overfit model. It's a model that's been trained on this history already. It behaves like you would hope. When those promos come back on, the model has now seen this data, and it very, very accurately lines up with the actuals that you see when those promos are I should say, turned off. An interesting thing in this bottom graph, this is a very small partner. I literally looked through our 40,000 time series and picked random ones. This is a very small partner, and you can see that the actuals actually drop below the baseline frequently. And what's happening here is big promos are running, and they're actually causing a pull forward in demand. And so the promo runs, and then demand drops below the baseline. And that seems to keep happening here. This would imply that that promo is not maybe as effective as we might think it is, because it's actually pulling forward demand that would have sold at a higher margin. So a valuable insight that comes out of this analysis. I'm going to do a time check because I don't want to keep you too long. OK, I got 2 more slides. I'll go quickly here. So forward baseline, again, we train the model on our full history. We backtest the model with the promos included, so we make sure that this model does, in fact, forecast very accurately when it sees promotions. And then we ask it to predict the future with promos turned off or set to 0. And so you get really interesting graphs like this, where you have a very volatile history. I've actually gone through, because I wanted to make sure I was showing you good information. So this series was, in fact, spiky because of lots of different promotions that ran. And when we forecast this baseline, you get a nice seasonal curve with some really trends or qualities that you would expect to see coming out of this analysis. So you see stable life cycle decay over multiple years. You see that the holiday impact is higher in your next holiday versus your holiday 2 years in the future. These are all, we don't teach the model this, it's just learn this by looking at history. This is a multi-year product. Here, different views, sorry, different Tableau report, and I couldn't make everything look the same, so my apologies there. But here, we've got our 2 different snapshots. So these are actual baseline forecasts that we generated. Snapshot 1 was generated in one time, and snapshot 2 was generated a few months later. And what you can see, snapshot 1, first of all, in all of the weeks, and this is another one where I went and actually double-checked that I was showing you good information, but all of the weeks where promos turned off or dropped very low, that's a very accurate forecast. You can see that it kind of runs along. It's like giving a haircut to the graph, basically. And then when we run promos, they spike up above that baseline. And you can see that it remains accurate all the way up until the recent week when I pulled this report. And then you can see that on snapshot 2, it basically continues to show the same thing with minor updates based on any new trends. So this is very, very stable. Even as the model is flowing through these spiky promo situations, this baseline is holding very, very steady, and this we observe really, really consistently. So we're very happy with how stable it is. We are actually working on, internally for our team, a flagging, an automated flagging report that would say, oh, hey, out of your 40,000 forecast, forecast 22,000 is jumping around a lot. You need to take a look. That's not something that we currently have in place, but we haven't really needed to have it in place because it's very, very rare that we see this destabilize. And the last thing we'll talk through here is our approach to promotion simulation. So this is something that the first time we saw these curves, to be totally honest, I really, really excited about it. So I've sadly had to hide all the axes here to obscure the data. But these are elasticity curves. So on the x-axis here, you can see the value of the promotion that we'd run. This is an X% discount off the MSRP of the product. And then you can see the uplift above the baseline that this promo would generate. I've got two different views of it here. So the top one is by quarter, and the bottom one is by hidden promotional type. And the quarterly one, you see some amazing things like Q4, the elasticity is much, much higher. That's exactly what you would expect to see. So here in this graph, we can see right off the bat, this is the value of running a promotional budget in Q4 versus 1, 2, and 3. On the bottom, you can see, promo type blue is a much more effective promo than promo type purple. Again, super valuable information. The way that we build this, again, same model, train and test on the full set. I mentioned with the baseline, we predict the future with all the promos set to off or 0. What we do here is we just brute force predict hundreds of different promo scenarios for the future in 5% increments by promo type everywhere all at once globally. So 5% every week at every partner for every SKU, 10%, 15, 20, price discount, trade-in, bundle, et cetera. Each one of those, if we did that in one at a time, again, it could literally take like weeks to generate all those scenarios. But we'll just scale it up with cloud. So what we do is each one of those is unioned together. I think this batch prediction table is over 500 million rows. And we just label each scenario with a series ID with series ID underscore scenario. And that's it. You union together this giant prediction table, and all at once you generate all these scenarios. And then you've got a giant BigQuery table available to query scenarios out of live by our users. We're looking in, full disclosure, we're certainly looking towards how can we make the model live callable. Right now we're handling this all with batch predictions. But this is actually working very well for us, even with the large compute required in order to make it happen. So I think that's all my slides. I think we have a few minutes left here, and I would love to answer any questions. Thank you all for taking the time to be here, though. We have plenty of time? Okay. I'm here. Yes?
You have to take a microphone, please.
Oh.
Take a microphone, please.
Excellent presentation. Thank you again.
Thank you.
My question is about the baseline, right? I think we work with a number of clients, and estimating the baseline is a big deal, right? So the way that you are estimating the baseline, you are unioning the scenarios, right? So how many periods, are you doing this every week, or is it just, every week you just do only for 1 week and then add the scenario?
So yeah, that's a great question. So for the backward baseline, every week we do, every week we were doing it for 1 week and joining that into the table, or unioning that into the table. We actually have built the capability to trigger a full rerun as well if we make a new model update and the model has a step change in its level of accuracy, so that we can actually go back and resimulate the entire baseline with a new model.
Right. So when you do that like at one time, right, in that case, would you be like running all the scenarios at once with one run?
Yes.
Or would you just like do this in an iteration each week and add it?
It's a great question. So yeah, what we're doing is all at once in one run. So because Vertex is able to scale up on our cloud compute, we do the one week at a time. So we have our context window with 1 week with promo turned off. Okay. Call that rolling window number 1 and label it accordingly, then union rolling window number 2, 3, 4, all the way down to rolling window, say 52, into one very, very large table, and batch predict the whole thing at once. And it'll take 4 hours instead of 2 hours, but the majority of the time is reduced, just scaling up on the processing needed to handle a very large table.
Okay, thank you. And you have the code available. It said link, right?
So that was a link to the paper for Tide. I can't unfortunately share the code for how we're doing this, but I'm happy to talk through the approach itself. So Vertex is a really easy API to leverage. So using Vertex, the code is pretty straightforward, to be honest. Yeah.
All right, thank you.
Hello.
Hi.
I think your talk is super interesting. I have many questions. Otherwise, you don't stop me, I will ask. So my first question is like you said run 100K plus time series models. Those are individual one, or you just connect them as a whole, or just one by one?
So great question. So that's our training data set. So our training data set has 100,000 individual series in it. Our prediction data set, we predict 40,000 series. But the model itself is a global model. So we're not building individual models for each series. We're building one global AI tool that can forecast all the series.
So at the beginning, you talk about this hardware demand, then it will be in a network, right? So if you model a network, that will be a network model, or how do you deal with those kind of time series?
A network model, or
this maybe beyond what you presented. Yeah.
So is your question how
because
do we?
Because Google is a huge company, you have many departments and also many demands.
Yes.
You model them simultaneously or just one by one?
Yeah. This is a good question. So this is just a model for demand for our
your unit.
Our unit demand, unit demand for the hardware, but we are modeling. We model all of it at the same time. So we train a model on all of our history, and then it's not like an ARIMA model where you would train one ARIMA model per series.
I see.
It's an AI model that is able to learn from all of the series and then predict all of the series simultaneously. So it produces a forecast.
I see.
Yeah.
Okay. So baseline has been asked. I also noticed that when you model this baseline, you have those very smooth, you have those spikes. Academically, like a spike and a smooth, they are, if we write a paper, that may not be publishable, a different story, yeah. So how do you also mentioned this like trend is accurate, how do you evaluate its accuracy, yeah?
So yeah, a really good question. And evaluating the accuracy of the baseline itself has been very, very challenging for us because there are certain weeks where if a promo was run, it's very difficult for us to know exactly how to consider the accuracy that week. So we do two things. The first is in our backtesting, we evaluate the accuracy of the model when it can see what a promotion is. So gaining that confidence that the model knows what a promo is makes us feel more confident that the model knows what a promo would look like if we turned it off. That's the first thing. The second thing that we do is we actually snapshot 2 different data sets, or all of our data sets. So we snapshot our weekly forward baseline predictions. And we also snapshot our weekly promo uplift simulation predictions. The promo uplift simulation tool, we do rerun every single week. With those 2 sets of snapshots, we can actually come back, a month or 2 later, and we can look at if we'd known what promos we're going to run, would the combination of those 2 tools together have been accurate? And the answer is that yes, generally, it's working very well in that regard. And I don't have the results here. For various reasons, it's difficult for us to do that in a way that's easy to share. We've got a lot of different series and a lot of different stakeholders who are looking for different types of accuracy on those series. But yes, it is actually working well in that regard as well.
Okay, maybe last question. I have more. So when you showed some very nice.
If others have a question, look. Okay, please go ahead.
Maybe I ask the last one. So you get this kind of spike. If like a short-term forecasting, in general, it will be like a one-time lag delayed. For the long time, it can be like matched for spike to forecast spikes. How do you deal with this kind of thing?
Sorry, is the question, how do we forecast spikes?
Yes, yeah.
So it depends what the spike is caused by. We do a really good job of forecasting spikes that are predictable, such as holiday or driven by a promo. There's other spikes that we don't do. We don't know. We don't know what causes them, or we have no way of predicting it. And so sometimes the spikes are just inaccurate. What's nice about our model is that when one of those spikes occurs, we observe that it tends to remain stable. So it's only if we get lots and lots of unpredicted spikes where we start to see a destabilization of the forward prediction. And I think that's because the model is trained off of a lot more than just that series. It's trained across many, many thousands of other series as well, where it's gotten a chance to observe how frequently a spike equals destabilization versus not. I hope that's a good answer to your question.
That's great. Thank you. Yeah.
Hi. Yes. Thank you again for an excellent presentation. I'd like to hear a bit about your journey of getting your operations and also your partners on board. I guess there may have been some resistance early on. Was there a point where you felt that you had won them over, or?
That is, I could talk for multiple hours about just this question. So I started building spreadsheet tools with no statistics in them. And I focused first for many years on automating spreadsheets for the planning team. And I think that gave me a lot of, it really helped me learn the way that those teams operate. I was actually on the planning team when I was doing this. It also helped me know exactly which places would benefit from additional automation versus places where it's very, very difficult to change people's minds. And so focusing on this baseline, there was a lot of resistance. A lot of people prefer just a single number. They don't want to think about a forecast as baseline plus other. They just want, my forecast is 1,000 units. And that's a tough thing to work with. But what I identified is that the baseline piece of it is the part that people are more willing to say, that's statistics, that's okay. What I care about is the stuff that goes on top of that baseline, like the strategy that I'm going to run. And so the design of our modeling setup is actually focused on what is the easiest part of people's resistance to overcome. So that's the first thing I would say. The second is it's a two-prong approach. We worked with our senior leadership and showed lots and lots and lots of different views of accuracy, MAPE and bias and long-term accuracy and offset accuracy, and it's been like a gauntlet of accuracy asks for various senior leaders around our organization. And then we do bespoke, one person at a time training and coaching and support for the actual planners. And our real goal here is to drive adoption by the planning team, not with leadership. I love my leadership, also do not care what they say, I just want to help drive adoption. It's not quite true, of course I care, but my real focus here is on the planners. And so it's really important to make sure that you never lose sight of trying to change the minds at the senior level, and you also can't lose sight of changing the minds of the individuals who are doing the execution. I hope that answers.
Thank you.
It's a multi-year effort, is what I would say, so it's just very slow. Hi.
Hi. So I think you said when you started using the type model that your computational time went down and your accuracy went up at the same time?
Yes.
Are you able to share what you did before using Tide?
So we are actually also using a different Vertex model. So Vertex has, I think it's learn to learn is the L2L. I think I'm saying this correctly, but it's an LSTM-based architecture. And Tide is a new architecture addition to the Vertex lineup. So the main thing we did is just switch from using this LSTM-based approach to Tide. And the LSTM-based approach is just a much more complex network, so it takes a lot longer to train. And then the accuracy doesn't. I mean, it's a great model. We had good results with the old model as well. But you lose some of that longer context and horizon accuracy with the LSTM network built into it. So Tide seems to do really, really well on long context windows. Does that answer your question?
Totally, thank
Wonderful.
you.
Any other questions for Evan? Well, I will take the opportunity to say that there's now a new addition to the Vertex lineup, which is StarryNet is now there. And so if you do check out Vertex, please check out StarryNet also, and you can think about which model is more appropriate under which circumstances, and the StarryNet has the explainability and may work better. I think Tide is actually really powerful when you have a lot of data, and so we try to have different offerings positioned for different needs.
We're really
Please check it
excited
out.
about StarryNet, by the way. I can't wait to try it.
One more question.
So just a quick question. So you still carry the 7 years worth of data, weekly data, in your modeling process?
Yes.
Okay. Is there any thought about maybe discarding some older data? Because companies routinely do this. Don't know why. I mean, is it because of hard disk space or what have you? They are stuck to this 36 months, 40-month mentality, right? After 3 years, the data is gone, right? It's a rolling period. And I think it's refreshing for you to say that, hey, 7 years, I'm still going to keep building data because hard disk is cheap, Google has so much space.
Yeah, so I will admit I'm very lucky to work at a company that is famously full of storage. No, we would be lost without the history. So we have a 3-year horizon that we need to forecast. Lots of key decisions made on a much shorter horizon. 1 month is important, 3 months is important, 1 year is important, but you need the whole 3 years in order to fully drive the strategic process. Trying to forecast 3 years without 7 years, that's the bare minimum we would need. And so I'm always, you will see me in meetings fighting tooth and nail to make sure that if there's a system change or something, that all data is preserved, because once the data is gone, you've lost it, and that is the fuel for any of this analysis. Yeah. It's 7 years weekly for us. Yeah, there's some tables that we have that are daily as well, but that's not how we're keying this analysis. Yeah.
So I also work at Google, so I should have asked this question of Evan ahead of time, because I did see this talk prior to the conference. Could you talk a little bit about how inventory is set on the basis of this model? And are there upper percentiles? Are you producing a distribution out 3 years ahead? And is that a different set of stakeholders than those who are thinking through the promo stuff? And yeah.
Wonderful question, and I could, again, talk for a very, very long time on this. So we're not using a distribution generated by our forecasting tool because in the strategic process that runs, there are manual inputs that drive our final forecast. So what we have is an enterprise forecast system where the final forecast, so we feed into that system as a signal, and then our planning teams will decide, we'll use our signal, but potentially modify it with strategic drivers. That final forecast that comes out of the system is the forecast that's going to be used to drive inventory. So what we do is we snapshot every single week the final forecast, not from our model, but from the planning system. And we do that over many, many years. And then we simulate, we sample with replacement basically from that distribution, or from that those snapshots to simulate a forecast volatility over time. Our inventory planning cycle is X months. So we take an X month forecast volatility, and then we do Monte Carlo simulation to optimize the inventory levels around that. So we're not directly consuming a probabilistic output of the forecast itself. We're recalculating that distribution. Yeah.
Great, thank you.
Okay, well, thank you, Evan, very much once again, and thank you all for attending.
Thank you all.